Okay, section 4.6, page 5. More examples here. A 6-foot man is walking toward a building at the rate of 5 feet per second. If there is a light on the ground 50 feet from the building, how fast is the man's shadow on the building growing shorter when he is 30 feet from the building? All right, let's draw a picture here. Building. Okay. 6-foot man out here somewhere, and a light on the ground 50 feet from the building. That man is 6 feet tall. All right, now what happens is that the light shines toward the building, and this guy's body blocks that light from reaching the building, but some rays shoot over his head, and they do hit the building. So it will be light up here. But this portion where his body is blocking that light, here's shadow. All right, clearly that shadow is changing, so we need to label it. Let's call it Y. And also this guy is walking here, and he's walking from the light toward this building. Let's call this distance over here X. And then this piece in here is 50 minus X. Here's our diagram, and if we jot down what we know and what it is that we want to find, then we can get started, or continue working, not get started really. Let's see, we know this man is walking toward the building at a rate of 5 feet per second. So that's dx dt is 5. And we want to find how fast the shadow's changing, so find dy dt when he's 30 feet from the building. Now 30 feet from the building is when x is 20 feet. All right, and once we've listed that, then we're good to go in terms of writing the equation to relate our variables x and y. And in order to do that, we are going to have to use similar triangles. See this big right triangle here? And this little right triangle with the guy. So we compare corresponding sides. So we can say y to 50 is equal to 6 to x. And there's your equation. Before we do a derivative here, I think that it's a little bit easier if we cross multiply and get rid of these fractions. So we'll have xy is 300. Oh, and let me just jot this down here. To set this up, we used similar triangles. And now we can do a derivative. And we do have a product rule here. So this derivative, the first x times the derivative of the second, dy dt, plus the second, y times the derivative of the first, dx dt, equals the derivative of the 300, which is 0. Substituting in the rate that we know that dx dt is 5. So we have x times dy dt plus y times, and dx dt was 5. It's all still equal to 0. And solving here then for dy dt, let's pull this 5y to the other side and divide out that x. So we have dy dt is 5y over x. Now we have solved for that rate, so let's evaluate it at 20. Let's find dy dt when x is 20. So x down here is 20, we have 5. Uh-oh, we need to figure out that y. We can figure out that y by using this original equation up here. Xy is 300. So xy is 300. We know x is 20. It's going to leave us with y is 15. Plug that in. Simplify here. Let's see, I'm going to divide a 5 out of those two. So we end up with, oops, negative 15 over 4. And that is how fast the shadow is changing. And see that negative? That tells us that the shadow is decreasing. So when we write this sentence, then we will say the man's shadow is decreasing at a rate of 15 over 4 feet per second when he is 30 feet from the building. All right, notice that our answer here in the work was negative 15 over 4, but I wrote positive 15 over 4 in here in the sentence because the negative is taken care of with this word decreasing. We could have said the man's shadow is changing at a rate of negative 15 over 4 feet per second, and that would be fine as well. Thank you. Please join me for page 6.